Hello students, I am Chiranjit sir from Electrical Engineering Department of Shantiniketan Institute of Polytechnic. Yesterday we will discuss about the basic control system, whether these are open loop control system and closed loop control system. So which is very superior? A closed loop control system is very superior than open loop control system because of in closed loop control system there is no any external disturbance because internal parameters are present here. It is under linear time invariant system, so it is a independent of time. Okay, so today we will discuss about the transfer function. So what is the transfer function? What is the transfer function? The transfer function is it is a defined by the Laplace transformation of output variables dividing by the Laplace transformation of input variables when all initial condition is 0. So what is the transfer function? The transfer function is defined by the Laplace transformation of output variables dividing by the Laplace transformation of the input variables when all initial conditions is 0. So basically the Laplace transformation of input and Laplace transform of output, how it will be done? Basically a system, it is a two types which are time domain system and frequency domain system. The systems are in two types. Number one, time domain system, and number two is a frequency domain system. There is a two type of system, time domain system and frequency domain system. The time domain system denoted by small t, and the frequency domain system which will be denoted by s. So a Laplacian transformation, it will be done by frequency domain system, which will be called a Laplace transformation. Therefore in open loop control system, this time domain function, it converted into a Laplace transformation or frequency domain function. It will be written as capital R and capital S, which will be at the, so it will be seen that a time domain function, it will be converted into a Laplace domain function or frequency domain function. So it will be seen that, or it will says that from the transfer function, the definition of transfer function, it will know that it is defined by the Laplace transformation of output variable dividing by the Laplace transform input variable when all the initial conditions are 0. So for open loop control system, the output, the Laplacian output is Cs and the Laplacian input is a Rs. So we can say that for open loop control system, open loop control system transfer function is Cs by Rs. So capital C S by Rs, which will be equals to capital G S, which will be gain. So this C Cs this Cs is a output Laplacian output Laplacian output this Rs is a Laplacian input and this Gs is a gain. So we can say that the transfer function for open loop control system is a Laplacian output by Laplacian input equals to Gs, which will be a gain. Okay, it will be says that for closed loop control system the transfer function is says that in open loop control system here there is an output and there is an input, so we can say is the Cs by Rs equal to Gs. But when we goes to closed loop control system, there is an input Rs, there is a output Cs, also again Gs, and here is another difficult problem is a feedback which will be a Hs, so that we can say that for closed loop control system the transfer function is Gs divided by 1 plus or minus Gs Hs. So for closed loop control system the transfer function is Gs by 1 plus minus Gs Hs. So what is the significance of this plus and minus? So it will be seen when the feedback goes to it summing point and the sign of the feedback is a negative, then we can say that this transfer function, it will be a positive. But when this feedback system, it will be a positive, then we can say this positive is going to be a negative. So this is the basic difference of the transfer function of a open loop control system and closed loop control system, where GS is a gain, here also G is a gain, and HS is a feedback. This HS is a feedback. So this is the basic difference of the transfer function of open loop system and a closed loop system. Okay. Now I will discuss about the order of the system. How the order of the system can be defined. The highest power of the S in the denominator of the transfer function is called the order of the system. Okay, so at first I will show you a small notes. This is a circuit. This is a input and this is a output. And what is this? This is a RLC circuit. This R, this is a R, this is a this is a R, this is a C, capacitor resistance R, capacitor C, and there will be a supply voltage. The supply voltage denoted by VI, which will be a time domain. So this will be denoted by T. The output voltage from the capacitor is V0T and resistance is a R. Therefore, when a KVL we applied, we can say that VIT equal to RIT plus 1 by C integral IT dt from the voltage equations of capacitor. These are input voltage, and when we taking the output voltage V0T, which will be a 1 by C integral IT dt. After that, I will do a Laplace transformation for this system. So we know that for Laplace transformation, all are in positive, all are in capital. Therefore, VIS equal to RIS plus 1 by C into IT dt. It will be converted for a Laplace transformation is 1 by CS into IS. IS is going to be a common. Therefore, we can write IS into R plus 1 by CS. After that, we will show you V0S, which will be an output voltage. So V0S equal to, here we will see that 1 by C integral IT dt, it will be converted into a Laplace transformation. Then we can say that V0 equal to 1 by CS into IS. From the definition of the transfer function, we know that it is defined by the Laplace transformation of the output variable dividing by the Laplace transformation of the input variable when all the initial conditions is 0. So we can write the Laplacian output voltage is a V0S, which will be a 1 by CS, and Laplacian input voltage VIS, which will be a R plus 1 by CS. So it is a V0S by VIS, output voltage by input voltage, and it will be gone to be a 1 by 1 plus RCS. It will be calculated. So this is the equations. So we can write from these previous equations, we can write capital T dot capital F equals to transfer function equals to, what is the formation, 1 by 1 plus RCS. 1 divided by 1 plus capital R, capital C, capital S. So this is the transfer function from the above RC circuit. Okay, so now we want to know that what is order of the system. So what is the definition of the order of the system? The order of the system is the highest power of the S in the denominator of the transfer function. The highest power of the S in the denominator of the transfer function is called the order of the system. So what is the order of the system? The order of the system, it will be defined by in the highest power of the S in the denominator of the transfer function is called the order of the system. So in a transfer function, the 1 is a numerator and 1 plus RCS is the denominator. So what is the highest power of the denominator of the S? Is here the power of the S is a 1. There is no any power, so there is a 1 power. So we can say that the order of this transfer function, so the order of this transfer function is 1. Okay, it will be very simple that how we can find the order of the transfer function. Okay, so next part, which will be a pole and zero concept and also a characteristics equation, it will be discussed in a next part of the control system classes. Thank you for watching.